Okay, now let's look at tangent. Tan of theta equals y over x. Okay, so in this case, y is 1, x is 0, so therefore it is undefined. So there is no tangent of 90 degrees, which is the truth. Okay, so let's look carefully at this question. It says, use the point P and Q to calculate the primary trigonometric ratios for 90 and 270 degrees. So let's draw this in. So here's our axes. Okay, so P is 0, 1, so that's here, P, 0, 1, and Q is 0, -1. Okay, and we want to know the value of the primary trigonometric ratios for 90 and 270. So 90 would be here, would be up to here, and 270 would be all the way around. Okay, so let's look at these angles. If you recall, we said that sine theta equals y over r. Okay, so if we're looking at the first one for 90 degrees, so theta equals 90 degrees. All right, so how do we do that? If you remember, y, in this case, y at 90 degrees, y equals 1, r equals, well, 1, because x equals 0. So if we were to draw some sort of triangle here, that would be really skinny, and we know that x squared plus y squared equals r squared. So if y is 1 and r has to be 1, so therefore x equals 0, r has to be 1. All right, so at 90 degrees, theta, sine theta, theta equals y over r, which is 1 over 1, which equals 1. So sine of 90 degrees equals 1. Let's look at cosine of theta. Cosine of theta would be x over r, but we know when theta is still at 90 degrees, okay, when theta equals still at 90 degrees, x equals 0, y equals 1, we don't care about it, so r equals 1. So cosine of theta equals x, which is 0, over 1, which is 0. So cosine of 0 degrees equals 0. Let's repeat this process for 270 degrees, which is all the way down here. Okay, so at 270 degrees, y equals -1, x equals 0, therefore on r still equals 1, because, you know, x squared plus y squared equals r squared. All right, so sine of 270 degrees equals y over r, which equals -1 over 1, which is -1. Cosine of 270 degrees equals x over r, which is 0 over 1, which is 0. And tan of 270 degrees equals y over x, which is -1 over 0, which is still undefined. Okay, so now you should fill those values in on the table at the bottom of page 8, and I'll summarize it when we get there. Okay, let's try this again, except with different points, 1, 0, and -1, 0 for 0, 180 degrees, and 360 degrees. So let's draw this in. So here are our axes. So P is now 1, 0. So this is point P, 1, 0. This is point Q, -1, 0. Okay, so we want 0 degrees, 180 degrees, and 360 degrees. So 0 and 360 are the same. I hope you see that. They're called coterminal angles. Coterminal means they fall in the same place. So 0 and 360 are coterminal. If you add 360 again, that's 720. They're coterminal. Okay, that's what that means. So let's start with 0 or 360 degrees. Okay, so again, x equals 1, y equals 0, and r equals 1. So sine of 0 degrees equals y over r, which is 0 over 1, which is 0. Cosine of 0 degrees equals x over r, which is 1 over 1, which is 1. And tan of 0 degrees equals y over x, which is 0 over 1, which is not undefined, it's 0. Let's do the same thing for 180 degrees. We have x equals -1, y equals 0, and r equals 1. So sine of 180 degrees equals y over r, which is 0 over 1, or 0. Cosine of 180 degrees equals x over r, or -1 over 1, which is -1. And tan of 180 degrees equals y over x, which is 0 over -1, which is still 0. All right, let's summarize. So when theta is 0 or 360, sine is 0, sine theta is 0, cos theta is 1, and tan theta is 0. At 90 degrees, sine theta is 1, cos theta is 0, and tan theta is undefined. At 180 degrees, sine theta is 0, cos theta is -1, and tan theta is 0, while at 270 degrees, sine theta is -1, cos theta is 0, and tan theta is again undefined. Just like our values of our special angles of 30, 60, and 45 degrees, these are values that you just need to memorize or be able to derive. Okay, so these are exact values. Again, do not use your calculator. Okay, do not depend so much on your calculator. These are numbers you just need to know.